Guys, welcome back. This is Dharaniya ma'am for you to teach you the binary search using recursion. This is another important 16-mark question in unit 3. Okay, first we will see what is binary search and we'll see how to compute this binary search using recursion in this series. Okay, now binary search is also called as half interval search. Okay, the other name for binary search is also called as half interval search. To do binary search, the element must be sorted. This is another important step. Okay, only in sorted array of elements you can do a binary search. Okay, remember that. And the next point is binary search uses key to perform searching. Okay, we will have a key which is nothing but the mid value of the elements. Okay, there are two ways of finding out the keys. Okay, if there are odd series of elements, suppose 1 2 3 4 5, there are 5 elements in my array, key can be easily found because it will be the middle number. Okay, if we have even number of elements, suppose 1 2 3 4 5 6 is my elements, how can I find the key? Because there are two possibilities. 3 and 4 are middle of the array. So in this case, you can just blindly follow this step. The first element in my center part is my key. Okay, so my key is 3. Okay, so this is my midpoint in this case, and this is the midpoint in this case too. Okay, so if this key is found and my search element is suppose 5, okay, first time I'll be comparing my key and the search element. My key is 3 and my search element is 5. I'll be comparing whether my element is less than or equal to the key. Okay, less than or equal to my key, that is I'll be comparing whether my element 5 is greater than my key. If this is the case, 100% sure this element will not be present before 3. Okay, so I can just cut it off. 1 2 3 4 1 2 3, I can just cut these 3 elements. Okay, now I can just blindly do the searching after 3. Okay, these 3 elements will be removed from the list, and this for the second time I'll just write and show you. Okay, if suppose there are 6 elements, okay, and my key is 3 for here, my key is 3, I want to search 5. Okay, my search element is 5. I'll be comparing my search element is greater than 3 or not. This is true, so I can just cut off till 3, till the key. Okay, now my new series will be 4 5 6. My search element is 5. Yeah, okay, now my new key is middle element, which is new key is my middle element, and my element to be found is also element to be found is also 5. So in this case my element is found. In the second iteration itself I can just find, this is the first iteration and this is the second iteration, I found the element. Okay, in case of linear search I need to search 1 2 3 4. I need to go 4 iteration to find my element 5. So that is the benefit of using binary search instead of linear search. Okay, in case we have a huge series of element. Okay, so this is how you just do in binary search. You'll find the key and you'll do this comparison. Since this is a sorted sorted array of elements, you can just remove the elements till the key value. Okay, and now my array will be smaller. I'll again find a new key, and again I'll just compare the key with the element to be searched, and if it is found, it is well and good. See, in this case we have found Ilya. So similarly you can just, so this is a rough idea of binary search. Okay, we'll move on to the program now. This is the smallest program again, which is only one page. Very easy, very simple. I've just taken only one page program for, okay, so that you can easily understand. And again I'll just explain line by line, don't worry at all. Okay, so my program starts from here. No, it is, the program doesn't start from here because my main function is not here. So just search where is my main function. It is here. Okay, so my program starts here. Int main void int will give me this is nothing but it will return 0 or 1. Okay, so they have mentioned it int return type. And now I'm just declaring my array. Int array is equal to 2 3 4 5 6. Okay, this is my array element. In this program I'm going to give my array directly and I'm going to give my search element directly. Okay, so this makes my program much simpler. My elements are 3 4 5 6. Okay, and my n is equal to size of array by size of array of 0. Size of array, what is size of array? 1 2 3 4 5. 5 into 2 because this is of int data type. Okay, we'll go to the working part. So here we have come here. Array is equal to, this is my array and the index of 2 is 0 1 2 3 4. Okay, the index of 6 is 4. And the second step, n is equal to size of array divided by size of array of 0, which is nothing but 10. 5 elements into 2 because of int data type will give me 10 divided by array of 0, which is 2. Size of 2 is again 2. So 5 divided by 2 will give me 5. Why I am dividing like this? Because to find the total number of elements. Okay, this is one of the way to find the total number of elements in an array. Okay, so I have found there are 5 elements in this array and my search element is 5. Okay, we'll move on here. The next step of this n is the x is equal to 5, which is my search element. Next next step is int result equal to binary search of array 0 and -1 x. Here I have called the function binary search with these 4 parameters. So the flow of execution from this point will directly move to the function where I've declared binary search with 4 arguments. Okay, so we'll see what is an array. Array is nothing but this part will be placed here. 0 n minus 1. What is n here? 5. Yeah, 5 minus 1, which is 4, and this is x, my search element. So after replacing this, it will be like this. Okay, array, first element, last element, I mean the index of the first element, index of the last element, and the element to be searched. So this is the arguments which are exactly going to be placed in this particular point, and you will be using these values in the statements given below the function. Okay, okay, the first step is if last element is greater than equal to 1. What is the last element? What is the last element? The last element is 4. Okay, I've given it here. Last element is 4. So the 4 is, I'll keep it here. Okay, the 4 is greater than equal to 1, which is true. There are only elements not okay. So this is 4 greater than 1, which is true. Okay, my midpoint, next come here. Mid is equal to f plus, I mean mid will be always found by the first element plus last element by 2. That is the formula. I'm just replacing the first index 0 plus 4 divided by 2 will give me 2. I want to just make it clear, these numbers 4 and 2 are only the elements, not array of 4. Okay, just don't confuse this part. It is not array of 4. Array of 4 means it is not this 6. It doesn't point 6. It is only the values. It is only a normal values 4, 1 like that. Okay. Once you have understood the program, you'll be very clear with this point. Okay. Okay. I'm here. My mid is 2 now. Now comes the next step. If array of mid equal to x, what is array of mid? Array of mid is 2. Array of 2 equal to 5. I'm just finding whether my mid value is the value which I'm supposed to find. Okay, I'm just checking whether my mid value is the element which I am searching. What is array of 2? Array of 2 is 4. No, the mid of this particular array is not equivalent to the element I am searching. So this particular statement is false. So if this is false, it has to go to the second if statement. If array of 2 is greater than x, I'm just seeing whether my array of 2 is greater than 5. What is array of 2? Which is nothing but array of 2 is 4. 4 is greater than 5. False. So from this point we can surely say that the elements before 4 can never be 5, because this is a sorted array. So you can just close your eyes and remove these 3 elements from the list. Okay, so that my list will be only 5 and 6. Okay, how will you write this particular idea in a form of statement? So my mid is 2, is it not? So I'm just cutting off this element. So what can I do? My mid element can be, the first element in array can be mid plus 1. Mid plus 1, which is nothing but 2 plus 1, 3. Then it is understood that my first element is 3. So these part will not be considered. Okay, that is the step for else part. I have just passed array, that is my array elements. First element is mid plus 1. My first element is mid plus 1, so that I'm just removing all these 3 elements. Okay, till my previous mid, I'm just going to remove all these 3 elements. So I'm just considering this element as my first element, which is nothing but mid plus 1. Array mid plus 1. Next come the last element and the element to be searched. Now with this parameters, again the function will be called. Okay, with this set of parameters, again just place array of element to this part, and now the mid plus 1 will be replaced with f. L will be replaced with L and x will be replaced with x. Wherever you are finding f, it has to be replaced with mid plus 1 value. Okay, here when I call this particular function, I've changed the arguments based on my requirement of the program. So this particular value will be replaced with f. F will be replaced with this particular value. Okay. Okay. So when this particular last function is called, your values will be mid is equal to, your new mid will be first element by last element. Here again we have to check whether my L is greater than or equal to 1. What is the last element here? My last element is 4, is it not? My last element is 4. Okay, 4 is greater than 1, true. My next statement is finding the mid value, first element plus last element. What is the first element? First element is 3. Okay, mid plus 1, 3 plus 1, 2 plus 1 is 3. 3 plus last element 4 by 2 is my mid, which is nothing but 9 by 2. I mean, this is wrong, right? Is it not? Which is equal to 3 plus 4, is it not? 3 plus 4, which is 7. 7 by 2, which is 3. So my new mid is 3. What is mid now? My mid is 5. Mid is 3. When I place it as array of 3, it points to this fifth element. Okay. Now I am checking whether this point is over. Okay. Whether I am checking array of mid, which is array of 3 equal to 5. Now absolutely my value 5 equivalent to 5, and it will return this value 5. So in this part, my array of 3 which is 5 equivalent to 5, the element to be searched. So return the mid. I'm going to return the value 3. Okay, so that is the output for the statement. I'm going to return the mid, which is 3. Okay, this 3 will be returned to the function call. So this is the function call, and this value of this function call will be returned here. So this place will be replaced with 3. Okay, so my result will be 3. I have a checking condition over here. I'm going to check whether the result is equal to -1. Result is 3. 3 is equal to -1, false. If this is false, this statement will be executed. If this statement is true, this statement will be executed. So in this case, it is not true. So the statement will be executed, which is nothing but the element is found at index %d, comma result. What is the result? 3. So this particular 3 will be placed in %d. So the output will be element found at index 3. Okay. Next is return 0. Return 0 is the success status that my program has executed successfully, and close the braces. So this is the simplest binary search program using recursion. When I use the term recursion, I have to say a recursion function is nothing but which calls itself again and again. So in this program, this is the function binary search. Here I've called this same function binary search, and again I've called the same function binary search again. So calling the function again and again is nothing but recursive function. Okay, the set of statements will be called again and again to do some computation. So that is the meaning of recursive function. Okay, I hope you understood. Just comment below whether you have understood or not. Okay, I hope your comments. I hope you will comment. Okay, thank you. Bye. To learn more engineering concepts easily, just don't forget to subscribe, like, and comment.